Thanks for tuning back in. We're going to talk about zone boards again. This is going to be zone board anatomy this time. Last video I just went over the do's and don'ts and what to say and how the zone system generally works, just from an observative point of view and using the meter. Didn't really go over how to wire that up and explain a lot of the reasons why those terminals that are there need to be wired if you're using a second transformer or a primary transformer. In today's video we're actually going to cover that in more detail, so stay tuned. We're not going to do any labs today. We're just going to take it right to the smart board, get right into it. I've got zone board anatomy behind me. This looks very confusing, but I want you to look at it a different way. I want you to look at this more like, hey, everything looks redundant, everything looks the same, it's just copied a bunch of times. So let's just look at this terminal block here. We have R, C, Y, Y2, O, G, and W2. If you can see that, the block here that's labeled heat pump and the block here that's labeled air handler, they have the exact same terminals. And I want you to look at this very simply, because when we go to this zone board, we're doing the exact same thing. Now there are a couple other terminals that aren't exactly like the terminal blocks on the thermostat, the heat pump, and the air handler, because we have RH, RC, we have the DATs, we have an RC all by itself, and we start getting into M1 and M6 and whatnot. So we're going to cover all that. We're going to cover what this is. That's a damper motor, a 2-wire. And then of course over here on this side, it's just the same thing, it's just redundant. So in that last video we covered that first come, first serve, and how do we depict which zone called in heat, which zone called in cool that was first, even if it was just a split second in between one thermostat from the next thermostat. We showed you how the dampers would respond based on the zone board getting that call. And so I can't really show you that here. That's why we chose to do that in the lab. Here I want to home in on how to wire this up and how you can simply understand it. Because even if you look at it like this and I say, hey, it's just the same terminals everywhere, it can still be overwhelming, and I understand that. You know, everybody looks at that and says, hey, that doesn't look hard until they pull the cover off of it. When you pull the cover off of it, whoa, okay, that's pretty complicated now. And it's not. You know, over here, I chose to leave all this blank just so we can take everything that I have on this screen and just block it out of your mind. And the only way I can get you to take this out of your focus is simply to just take it out of your focus. Let's look at this. I have 3 terminal blocks. We have the thermostat, the heat pump, and the air handler. Now this could be just a straight cool. Of course you're only going to have 2 terminals, Y and C. You're just going to have a contactor to wire up. You won't even have a terminal block for that. We're taking all the fun out of this if we just talk about how to wire a straight cool. So we're getting right to the meat and potatoes, the complexity of it, the heat pump. If you notice here, I'm focusing on the Y2 now, so we can integrate that second stage, because a lot of our equipment is 2 stages or more. And so if I were to wire this up, very simply, we can look and say, okay, well, I need to have, and I'm going to try to do this within color code. We're going to take red, and we're going to come right over to the heat pump. We're also going to take red. We're going to tie it over here to the thermostat. We're going to take common. We're going to take it right over to the heat pump. We're also going to take this common, and I'm going to cross over my wires because I'm using different colors. We're going to take it right up to the thermostat. And so the unit transformer, which is known as the primary transformer, okay, is now wired to the what would be the defrost control board. Okay, and that's what this block would represent. And this would be the air handler block for, you know, all your wires that converge inside the air handler if you were to just kind of pigtail everything in there. And there's nothing complicated. You typically wire your systems all day, every day, in this manner. I'm just going to switch the color up, and it's just a wire for wire. So if you can see here, I'm going to come from the thermostat this time. I'm going to come into the air handler, and then out of the air handler we're going to go to the condenser. We're just going to keep doing this. We're going to come out of the thermostat with a Y2. We're going to come into the air handler and tell it, hey, run on Y2. That's going to send the signal outside, hey, run on Y2. Same way if we're energizing the reversing valve. The thermostat will send that signal over to the air handler. Out of that, it'll go over to the heat pump. Now I did put a G over here, so I'm going to go ahead and just say there is no G. So we're just going to put an X on that. So let's go ahead and go to G now. Coming out of the thermostat, we're going to come out and go right into the air handler, and that's it. Same way, W2, out of the air handler, over, or out of the thermostat over to the air handler, and then out of the heat pump, coming back this way. And that's it. So there's nothing difficult about that at all. And so there's no zone equipment here, there's no dampers, that's just a air handler, your heat pump condenser unit, and one thermostat. The moment you start integrating more thermostats, we're going to cover that. What does that look like? If a customer wants to zone their house out, what would that look like? So we're going to come over here, and we're going to have to erase pretty much everything we just drew up here, because I am going to take and mark my G call back off, because that's not going to be there. Alright, so what would we do? What would we do if we wanted to add more thermostats to it? Okay, so pretty much this is what we're going to look like by the time we're done. Let's see, how many things can I delete? Let's see here. I've got, let me do it this way. I'll go ahead and remove that. So this would represent a damper. It's just a 2-wire damper. Once we energize it, this damper will close. If it's not energized, the damper will stay in the open position. And so if I wanted to have another thermostat, then what I'm going to have to do is I'm going to have a zone board basically. So I'm going to go ahead and add 2 more thermostats. And let's try to do this without a zone board. Let's just see how crazy that's going to look. We're going to wire this again. We're going to start off with R to R, R. Let's go ahead and wire this thermostat over here too to the air handler. And let's go ahead and wire this thermostat over here to the air handler. We're going to go ahead and take our commons back and bring that outside. We're going to take our common from this thermostat and our common from this thermostat. And so far nothing crazy's happened. We have a display on all 3 thermostats. Okay? Let's go ahead and take it a step further, and let's start wiring up our Y calls. So this Y will come over here. Okay? This Y call will come over here. This Y call is going to come over here. They're all going to be in parallel at this point. So any one of these thermostats can call to bring on this air handler and condenser on a Y call. Right? Let's go ahead and take a Y2. Let's go ahead and energize the air handler from all the thermostats, Y2, and then we'll take Y2 directly to the heat pump. Any one of these thermostats can call for low speed or high speed compressor. Let's go ahead and add a couple more in here. Let's go ahead and let's go orange here, and we're going to go ahead and do the G call next. Alright, so we're going to say O, 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 and then O out. We're going to say G, so we can run the fan from that thermostat. G, so we can run the fan from this thermostat. And G, so we can run the fan from this thermostat. And we're going to go ahead and just add a W. So this thermostat can call for the electric heat strips to come on. This thermostat now can call for the electric heat strips to come on. And this thermostat can call for the electric heat strips to come on. Now, of course, the defrost control board during defrost, it needs to tell those heat strips to come on when it's in a defrost. And so there's no zone board here. We've just taken the air handler, the condenser, and 3 thermostats, and we said, hey, we want, there's really no zone system here. We just have thermostats all over the place, and they're all in parallel with each other. And when things are all in parallel with each other, one thermostat is pretty much the same as having 3 thermostats. It doesn't matter. You're just going to, you're going to get a balance of temperature, but what you cannot control is where one area of the house overcools or overheats, right? So that's not a way to zone. And these dampers can't close because there's nothing here to tell those dampers if I only want this thermostat to call, okay, and I don't want this thermostat to call or this thermostat to call, there's absolutely no way to have those areas or those zones shut down. And so this is just ridiculous, and you would never do this. So we're going to go ahead and just erase this because it's not practical. But at the end of the day, I have not inserted a zone board yet. So if you want to look at that for a second before I erase that, let's look at this image here. We're starting all over again. And it's a nice clean image. We have our air handler, our heat pump. None of the thermostats are labeled, but you know that these are thermostats. You know that they're thermostats because we just wired them all up. You know these are dampers that cannot be controlled because there's nothing to tell them to shut the airflow off in that area. So just look at this a little bit simpler. All we have done is we've just now have said, hey, look, you know what? Instead of coming directly over to our equipment with these 3 thermostats, we're just going to run them into a zone board, and then the zone board is going to take that message and it's going to send it very clear on what the equipment needs to do. And whatever zone does not need air, then it needs to have the ability to shut that zone down via a damper motor being energized so it can close the damper so air cannot get past it. And it's that simple. So we're going to come back over here, and what we're going to do is we're going to just erase this ridiculous wiring. It's just not going to work. You just need to train your brain on how to look at this very simply. There's nothing complicated about it. Anybody typically that's done this within the first couple of weeks of doing startups on new construction may not even understand what they're doing, but they know to connect all the dots. So let's just look at this. If I were to take the next image and uncover that, now we have what we have on the previous screen. So this is zone board anatomy, and I'm going to try to simplify this as much as possible. So it wasn't simple the first way, even though we simplified the understanding of these 3 thermostats and the air handler and the heat pump. But now all we have done is we have just put a zone board in the middle of all of that. And so now we want to label thermostats, we want to label the zones on the zone board so we can very simply understand, what goes to what. So we would say this is T-stat for zone. I'm just going to call this one zone 1. And if that's zone 1, then we can say that everything here is zone 1. I'm going to use a different color for my next zone. I'm going to just use this green looking color here. I'm going to say this is zone 2. I don't know how well that's going to show up, so I'm going to just darken that up a little bit. Funny, what I can see and then what you can see on the camera are not always the same colors. So we're going to go ahead and we'll just do a dark purple. We'll say this is zone number 2, and we'll just call this area here zone 2. And so I'm not going to write zone 1 and write zone 2. I've color coded it for you. All right? You just need to systematically break down your zone board and understand where power is coming in and where the controls are going to be at that are servicing the equipment side. Equipment meaning not thermostats and dampers. We're going to come over here to this last zone, and we'll just we'll go orange here, and we'll say this is zone number 3, and that's going to be this area right here in orange. So we have zone 1, zone 1, zone 2, zone 2, zone 3, zone 3. And so I have the discharge air temperature sensor that's going to go here. So I'm just going to go ahead and just take that and make that a different color. I'll go ahead and use green for that. So I'm just going to color this green and say that is all by itself. That goes to the discharge air temperature sensor. And again, we have just isolated a little bit more of our zone board. Now I'm going to take this black here and say that this area in black, this is for the equipment, which the equipment is going to be pretty much this outlined area here. All right, so this is equipment, this is equipment. Okay, we have R and C. That's obviously going to be power. So I'm going to just draw red around that, and that will identify that that is power. So I told you I was going to talk about 2 different types of transformers, primary and secondary, and how to wire that up. And in the last video, I did not really cover that wiring as far as, you know, if we wired it with a primary transformer. I covered it very vaguely, and I mostly spoke about the secondary transformer. I'm going to do it both ways here, because you can take the primary 40 VA transformer out and put in a primary 75 VA transformer, and primary meaning there's only one. It's one transformer that's servicing the equipment and the zone board. So if we step that volt amps up to a 70 VA, then we can carry the load of these dampers and energize these thermostats without causing a voltage drop, which would increase the amp draw and create problems, right? So we don't want that. And so this 3-zone, kind of like an air traffic controller in a sense, where it's paying attention to what's going on with these 3 areas of the home, and it's making sure that, you know, certain things can come on and run as long as they're in the same mode, and it'll give air to those areas. But the moment that those areas start to change their demand from a heat call to a cool call, or from a fan auto to a fan on with a heat or cool call, then it's gonna identify what came first, and if the fan call has always been there, it'll close that zone down, as you saw in that last video, because that's a cooling demand or heating demand is going to override the call for fan only, right? And so we covered that in that last video. And so this is more like an air traffic controller, where it's making things operate safe, you know, in the sense that it doesn't want, you know, anything crazy going on where heat's going on and cool's going on at the same time. Reversing valves are shifting back and forth. Dampers are opening and closing. There's no time delays, and compressors wind up short cycling, and then you wind up having issues. And so you basically the way we wired it the first time, that's exactly how crazy that is. So everything has to funnel through this zone board. And so we're just going to wire it one more time, and I'm going to do it one zone at a time, and then we're going to run the equipment last. And so just running with a primary transformer, okay, one transformer, a 75 VA transformer. So I'll go ahead and write 75 VA primary. Okay. All right, so we're going to say, we're just going to connect the dots, and I'm going to stay on one color all the way through. Okay. With that, M1 and M6, M1 is common, okay, M6 is power, and so for us to wire this up, we would literally just send power up, and let me go ahead and get common next, and we would run common from M1 to here. We would go power to from M6 to red, and then we would go M1 to common. Same thing up here. M1 would go to common, and M6 would go here. And so the moment 24 volts releases here, dampers will close. Where else am I missing 24 volts? I'm not going to wire the equipment yet. I'm just going to continue to wire the thermostat. So we're going to go ahead and put a common out. Now our thermostats can light up. And then we're going to go ahead and knock out our Ys. Alright, so if we knock out our Ys, pretty much we're just connecting the dots, just like we did in the very beginning. Y2, 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 Y2. I'm going to go ahead and get on my next set of colors, which will be O and the G call. Alright, here's O. Just connecting the dots. And we want to go ahead and do our G. Run our G over. And then finally we want to land our W2 from our thermostat to our zone board. And we have just wired all three dampers and all three thermostats. What we have not done yet is we haven't wired our DATs yet, and we have not wired our equipment yet. So I wanted to do this last because if we're using one transformer, then what we're going to do is we're going to send, obviously, I'm going to go ahead and just erase this 75 real quick. You've seen it. We're obviously going to send power out to the heat pump and common back. Okay, that's going to take place. But what we're going to do here with one primary transformer is we're going to run, there's going to be an RH and RC jumper already here. Okay, we're going to go ahead and run this 24 volts here over to here, and to power the actual zone equipment, we will have to run a jumper down and energize the power section. So this is now getting powered from the actual transformer that's inside the air handler, the actual equipment itself. Okay, and so the common basically will come back up, and then there you go. And so now these three thermostats and these three dampers, they can operate because we just applied 24 volts from the primary transformer, the 75 VA transformer, to the board. And if I do not run a this pigtail back up to here, right, then there's no way for the equipment to take the 24 volts here and relay back to G, O, Y2, Y, W2, or any of that stuff. And so this is just an extension of what your thermostat already does. That one thermostat does this. So, you know, how we originally wired it up in the very beginning with just this one thermostat to the air handler and the heat pump, Now we're here. That's exactly the same thing. This is now this. This is actually this times 3 because you have 3 thermostats, right? But now this zone board is going to be able to catch and know which mode to put it in, heat or cool, fan and on, and which damper to close. That's the job of the entire zone board to do. To take this information that's coming in and send it out, according to the order that it came in, based on demand and what's priority and what's not priority. And so if I were to wire the rest of this up, I'm going to go ahead and just get all my colors, take care of those Ys. All right, we're going to have yellow over to here. All right, yellow out to the condenser. We're going to have black on Y2 coming over to here. Y2 going out to the condenser. I'm going to go ahead and get on my next set of colors, which will be orange and green for fan. And we're going to have O come out from here, O going out to the heat pump condenser, and then we're going to have our G call here. There is no G call from the condenser, and then we just have to land our W2 now. At W2, we'll go from the equipment side of the zone board over to the air handler. The heat pump is sending the signal for W2 to be energized during a defrost. So even though you see it all connected there, it's all in parallel at that point, but the signal flow is what I'm talking about. Where's the message coming from? This is how you would wire the zone board if you're using one transformer. One transformer. If you miss this one step here, where you do not you don't take this jumper and run it up, to RC and RH, you've got this part wired right, but none of these thermostats say they don't have any batteries because you don't need them because you're supplying at 24 volts alternating current to have the display. So if you have batteries, it'll confuse you because nothing's going to happen. Nothing's going to happen because nothing is energized, and if nothing's energized, then there's no 24 volts here. All right, so by putting 24 volts here, let's go back to that one step. By putting 24 volts here, this 24 volts here is now supplying power here. It's supplying power here. It's supplying power here. Okay, it's also supplying power on M6. It's sending power up here to this M6 here when needed, and it's supplying power to this M6 here. All the rest of the power on these terminals, it's being relayed back from the thermostat. So if I need power on Y, well, red's just going to send power on Y. And I'm not trying to give you a thermostat class. We're supposed to kind of be past this point if we're talking about zone boards, because all that is an extension on understanding thermostats. If you can do a thermostat, doesn't matter what part you're in and as far as level wise, if you can wire a thermostat, you can wire a zone board. Alright, so I'm going to erase this and we're going to do it again, but we're going to do it with 2 different transformers. I'm going to go back and label that one thermostat. There we go. And yeah, I know this is color coded. You know where they're going now. Purple, purple, orange, orange, like pink, pink. Okay, and so you got to be able to strip away, that take the training wheels off. There you go. I've said it. So we've taken a little bit of training wheels off, and we didn't color code anything anymore. But I left your zones here. So if this is zone 3 thermostat, that's zone 3 damper. Matter of fact, what I could do is I could label it. And we'll come over here and we'll just say one. Putting the training wheels back on, why not? 2. 3. This is equipment. This is equipment. Okay? So, took some of the training wheels off. So we'll just leave the thermostats here, dumb down the confusion a little bit, and I'll leave everything else the way I have it. Okay, so using a second transformer, I'm going to go ahead and introduce our other transformer here. We have L1, L2. Obviously, this transformer will be found inside the air handler. So if I had a primary transformer that the manufacturer put there that's a 40 VA, and I'm putting in a zone system, you know, whether I buy a kit or don't buy a kit, I would take a 40 VA transformer and I would add that. Of course, I would have to power it with L1 and L2, so I have 230 volts, so I can step power down to get my 24 volts. All right, so we're kind of do things a little bit reverse order here, and I'm now going to say we're going to take common. All right, I'm going to go ahead and draw my arrows here. I do not like that arrow. Undo. There we go. I'm going to say, let's do it this way. Power out, power in. There's my arrow. We'll say common back to the transformer. There we go. And so now that we have supplied 24 volts to the zone board, none of this is going to be over here. None of it. This is only going to put 24 volts here, here, and here. So at this point, what we're saying is we're going to have 24 volts here, 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 here on M6, here on M6, and here on M6. And that's it. And with that, then we can now energize 24 volts going to these thermostats on all 3 zones. And that's what it's going to take, is to put that 24 volts here, and then through the zone board, your zone board's landing 24 volt power supply on every one of these. You're never going to get a signal back on anything else. Never. But if I were to sit here and just take a wire and say, I want to just test my zone board out, I can take red and energize any one of these, and you know, as long as I have 24 volts primary here, then the moment I take 24 volts here and energize it on, say, G, for example, then I should see 24 volts appear through the zone board right here. Okay? And so then I'll have 24 volts leaving. And so this is the primary transformer. This is the secondary transformer. Okay? And so through the zone board, we're supplying all this power. Remember the RCRH jumper? That's always got to be there. A lot of these thermostats will have an RCRH on them, and the jumper will be there. I don't write that on there just because I think it's well understood, and that jumper is already supplied for you. And so power would be coming this way. Now you notice we don't have a common over here at all. We don't need it. You just don't need it. Okay? And so I have to have 24 volts to come here. And now it's the same thing as me having the 24 volts here. But what you have to understand is the 24 volt primary that's coming from the equipment, it's isolated. It's only in this area. It's nowhere else. It's only in that area. Nowhere else on that zone board where you read the 24 volts here. Because the secondary transformer is sending power here to light up the zone board, and it is what is the secondary transformer is what is energizing all these thermostats and these dampers. All right? And so everything else that I have here on the zone board is a input. The zone board only puts power out on M6, right? It sends power out on, it sends power out on red, 24 volt primary, right? Just erase that step. Sends power out, right? It sends power out M6 up to the damper, and it sends power out of the zone board up to the thermostat. That's it. And you have to simply look at it that way. Understand where your 24 volts is going. Your key terminal is R. Your key terminal here 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 is R. Okay, your key terminal here is R. Your key terminal here on M6, it's R. M6 is R. M6 here, it's R. Those are your key terminals. And so if you lose 24 volts here, then you will lose 24 volts on all those other things, and absolutely nothing could happen. It's impossible. And so using a secondary transformer, the primary transformer, if you still have R here, well, you have here R on standby. Okay? But if you lost 24 volts here because L1 or L2 was dismissed, or you blew a fuse on your transformer, or your transformer was blown, or whatever the case may be, this is not something that you would, people ask, hey, well, if I had a float switch, which R would I break? It doesn't matter, because if I put a break here, all right, every one of these thermostats are not going to be able to put power back to these other terminals, and now this zone board can't put power out to the equipment. So I can break here with my float switch. And if I did that, well, then guess what? If I wasn't using any batteries, then all my thermostats would just go blank. The zone board would go blank. Somebody could come over here and go, I still have 24 volts here. That's because they're not understanding, well, that secondary transformer, we broke power on that secondary transformer. That is one way to do it. That way the customer knows, hey, look, I lost power on all my thermostats. Okay, yeah, well, maybe they wired the float switch in to break R off of that. That's one way to shut the equipment down. Another way to shut the equipment down, and this is what happens a lot, is people will put a float switch here. Coming out of the air handler, going to a float switch, obviously coming back up, and then as it leaves, if that float switch is tripped, you're not leaving with energy to go to that zone board. And if you don't have that energy sitting there, that 24 volts sitting there, then no matter what is going on here, they can all be calling, but your equipment can't relay the 24 volts to the corresponding terminals for those outputs to come back in internal and blower motors and run compressor contactors and reversing valves, right? And so people get confused with these secondary transformers, and I don't know why. It's a very simple thing, but you got to be able to take an extension of your understanding on how the thermostat works, okay? Which is all a thermostat needs is 24 volts here, okay? And the moment it calls, it's going to wind up relaying that power to all the corresponding terminals. Everything will be an output back to the zone board as an input, and then the zone board will figure out what damper it needs to open or close, what dampers it needs to, what thermostats came on first for heat or cool, if there's are two different modes that called within a fraction of a few seconds. And it will allow the equipment to operate. Everything here is only an output because we have 24 volts coming to the equipment side. Okay, as far as the DATs, that's going to go to a discharge air temperature sensor that's in a supplier plenum. That DATS reads a certain low limit. Once that low limit is reached, say you want to always operate above 50 degrees in your plenum. You start dipping into the 40s, you're going to probably freeze your coil, and that's going to cause significant oil loss on the compressor, and the customer's not going to have air conditioning either. They're not going to be transferring heat if there's a block of ice on the coil. And so that discharge air temperature sensor is just reading the resistance coming off of that sensor, and most of these zone boards will display a temperature. Now, if you have an older zone board, that's why I did this one. This doesn't say Honeywell, this doesn't say White Rogers, this doesn't say really anything. Honestly, this is just our anatomy. We kind of built it. Does it look familiar? Yeah, because it's the same terminals. It's a 3-zone zone board. It's obviously capable of running 2 stages of heat, the way I have it mapped out, and it's capable of running 3 zones, and very simple. This is very, very simple. And so if we just want to go back to the beginning, just wire this up. We're going to go ahead and wire this whole thing up. We're going to take the training wheels off now. We're now going to take and erase everything that you see here, and we're just going to rewrite it. Okay, let's go ahead and label some of these zones again. We have 1, 1, 1, 1. Okay, we have 2, 2, 2, 2. All right, now we're going to go ahead and get to our last zone. We're going to say this is 3, 3, 3, 3. We're going to do this dual transformers, okay? And we're just going to connect all the dots. It's going to be very easy. We're first going to run the air handler into RCRH. There will be a jumper there between RC and RH. Okay, we're going to go ahead and take 24 volts off our secondary transformer. We're going to go ahead and wire that into our zone board. All right, we're going to go ahead and take our M6 up to our dampers, and we're going to take R and start coming over to our thermostats and landing them, and we're just going to repeat that process. Okay, we're going to come out here and wire that heat pump up. All right, now we're going to come over and we're going to take common and we're going to wire it up. Okay, all the commons are done. Now we're going to go ahead and do our 2 Y calls. Go ahead and do that second Y call. We're going to go ahead and get into O and G. Okay, we're going to go ahead and wire G up. Okay, remember there's no G from the heat pump. My mistake for putting it there. We'll go ahead and just put an X there on that terminal. We're going to go ahead and do our last terminal, W2. And that's it. And so we have just simply wired up our entire 3-zone system. Okay, refer back to the other video where we actually went over the observation of zones opening and closing and getting the meter out in that lab. But can't harp on enough on that signal flow. All you're doing here on the anatomy is it's just an extension of a thermostat. You just got 3 of them, and your zone board is basically a thermostat. It's just not reading the temperature. It's just taking the information from the thermostats, and what it would normally do to your equipment block, it has an equipment block that it will release. So it's just an extension. Everything's just an extension. Everything's very redundant. And so it's a very simple thing. Don't look at it and say, hey, I don't know how to wire that up. That's complicated, because it's not. It's not complicated at all. And so I hope I made this very simple for you. I hope you better understand it. So when you look at something, that needs to be wired up, you can simply look at it very simply and say, you know what? All of this is one zone. All of this is another zone. And then all of this is another zone. Dual transformer. If I'm using a primary transformer and no secondary, then I'm going to have to send power from my air handler over to here. Obviously the R, H, and RC are jumped, and I'm going to have to come down and pigtail that R. So looking at that, that one step again, I'm going to take, let me go ahead and just 24 volts into here, right? I'm going to put that RC, RH jumper on the back end, okay? And then we're going to go ahead and just come out of here. This is if I'm running it with a primary transformer. I'm going to put my input down here. Okay, that primary transformer, there you go. I've got to come in so my equipment can relay the power back out, but I have to in parallel power my zone board so I have 24 volts on all the corresponding terminals to put power out to receive power back. The common, there's no common over here, okay, but where you will need to put common is you have to have a path back over here. So just take note of that step. So there's no common to go here, and this is if I was using a primary transformer, 75 volt amp. Everything else is just connect the dots. So this is really the only thing there. I'm either going to run a secondary transformer all by itself over here, and it'll look like this, or if I'm running a primary transformer, it'll look like that. Pretty simple. Pretty simple. And so, take advantage of the zone board that comes with a kit, and it has a transformer in there. That way you don't have to use the extra transformer that you're stocking on your truck that you may need for a service call. If you buy a kit, typically it's a little cheaper getting all these components. All right, I'm going to go ahead and leave you off on this last page here, which is dual transformers. Okay, and so we'll just go ahead and write that down. All right, you got the primary in here, the secondary over here. So we'll just go ahead and over here and we'll write secondary. We'll come over here and we'll just put primary. And we'll just say 40 VA, and we'll just call this one a 40 VA. Running two 40 VAs, or you can just go back and just wire it the other way as a single transformer, 75 VA. All right, as always, like our channel, give us a thumbs up. Subscribe if you haven't done so already. Share this with others. There's a share button right there. Hit that share. Support this knowledge by sharing it with others. You can't reach everybody. That share button can get there a lot quicker than you. That text message, phone call, hey buddy, I found somebody that can simplify a couple things. Check him out. Leave me a comment. I read those comments. Past this, I'm going to get into zone designs. I'm going to talk about how air is distributed and some of the common problems that we have in this industry, and I'm going to try to simplify that for you so you can level up there and be more confident when you're looking at a zone system, so you can see the things that aren't supposed to be there that have been done so you can fix them, or if you have to take somebody that does not have a zone system and talk about a zone system, how you can confidently understand how many dampers that house is going to need to satisfy all the areas that they want to control at different temperatures. Obviously subscribe, please do that. We appreciate all your support. Stay tuned and stay safe. Thanks.